Hello and welcome everybody to Kubernetes Online Masterclass series. This is a weekly class that we hold here at Rancher, and we bring you good topics. But before we get into that, good morning, good afternoon, and good evening, depending on where you are joining from. We had several hundred people registered for this class, and we are expecting many of you to join again. Typically, we do get anywhere between 300 and 700 people joining these classes. This is a new series, still relatively new. We started it about a month and a half ago. Each class in the series is about an hour long. We do about 30 minutes of live Q&A. We cover a variety of topics, but everything is related to Kubernetes and containers. And just to give you an example, some of the past classes that we have run included things like up and running with Windows Server containers, preventive security. We have had 2 security related classes, in fact. And today we are going to talk about something that will be of high interest to developers and DevOps folks, CI/CD pipelines and Kubernetes. There are many people who have tried to solve it, and today see a solution or an approach from one of our partners, JFrog. But before I get into that, let's talk about why we do that, why we are launching the series. Well, we talk to thousands of Kubernetes users every month. We go to DockerCon, KubeCons, all the conferences that you can think of. We collect a lot of user feedback. We have hundreds of customers who give us direct feedback. We have a community of tens of thousands of users, millions of downloads. And again, we get a lot of issues and feedback from them. And based on that, we identified that there are some issues which are common across all companies, across all verticals. And these relate to some of these things that I'm listing here. So we thought if we start this online masterclass series and make it a series and make it extremely easy for you to find the answers, then it will benefit everybody, and we will learn from you, you will learn from us. Hence, we have tried to do that, and so far we have received great feedback. Thank you very much all for joining. So my speaker today, so by the way, just for the online masterclass series, if you want to see other topics or if you want to access recordings of some of the past topics, then you can do a Google search for rancher.com and masterclass, and it will come up, or you can note down this link and go there. If you're looking for something to get started with Kubernetes, we have another class, and that is about an hour, 90 minutes long class. Actually, it takes you through just the basics of Kubernetes, how to get started, what you can and cannot do, or should not do. It's a very good class. We run it every Thursday morning. And again, you can go and look up the schedule and the recordings of the past by going to rancher.com/trainings. Today, our speaker is Mark Galpin. Mark works at JFrog, where he is the senior product manager responsible for Kubernetes deployment of JFrog applications like Artifactory. He also works on integration, so he can talk a lot about what's happening in this space, as well as CI/CD. And my name is Ankur Agarwal. I'm head of product management here at Rancher Labs. What I do is I look at all the questions and try to answer them, and as well as I look at issues that people are reporting, where the space is going, problems that people are facing, and I try to solve them both through products or just by giving some examples of what others have done. Prior to joining Rancher, I built and ran CubeShift.io, which was an accelerator focused again on CI/CD and container delivery. I've been in DevOps space and cloud computing space for over a decade, and I've built several cloud products for companies like VMware, Mercury Interactive, and now Rancher. So while we are in this class, I will try to answer your questions on chat. And we will answer as many of them as possible. And just a few rules. We know that we are not going to finish on time. It just doesn't happen, because we get tens of questions, sometimes hundreds of questions, and we try to answer as many of them as possible. We do try to stay back if the questions keep coming. And we get all sorts of questions. So please do not hesitate to ask very basic questions or very advanced questions. We have developers who can answer those questions if we can't. And if you want, you can follow up with us, and we'll be happy to answer those questions after the class as well. This session is being recorded, so we get a lot of questions about whether this is being recorded, how can I access it? Well, it is being recorded. You can go to our YouTube channel and find these recordings, or you can just search for rancher.com Kubernetes Masterclass, and you can get all those sessions as well, for which we are recording. With that, let me hand it over to Mark, who will walk us through CI/CD pipelines for Kubernetes. Mark, all yours.
Thank you, Ankur. And yeah, as Ankur said, I'm a senior product manager at JFrog, and I wanted to give this class to share our experience from a number of kind of different perspectives that we have. As Ankur mentioned, my team does the management of the Helm charts and Kubernetes deployments on various different Kubernetes environments that we partner with. And also additionally, we run a number of production grade Kubernetes applications. You may have heard of JFrog Go Center, which is a central Go repository. And then finally, I personally, as a product manager, have interacted with hundreds of customers who are doing container migrations, starting out with Kubernetes, and many of these ideas have been refined both at JFrog and in conjunction with talking with those customers over the years. And to start out this talk, just to kind of give the basic message, we're going to talk about the development of CI/CD and kind of how it developed. And the reason I'm taking almost a historical approach is that the reality is that as we grow CI/CD, for the most part, we're adding more on top. We're not really eliminating things that we used to do in favor of something else as much as we're doing more and we're getting a higher quality solution out of the work that we do. And so if we look historically, when I started development, when we talked about development, we talked about the application. And then some years back now, we started talking about the Docker container. And now today, we're talking about the Docker container in Kubernetes, hopefully, as we'll discuss, using a Helm chart. And then at the very end of this, I'm going to kind of walk you through what all these CI/CD layers look like, how you make them work together. And at the end, I'll walk you through a very quick demo where the source code is open source that you can kind of look at and see the same things if you want to look at it yourself. So let's start at the beginning. Let's start with the application. Now, back in the day, and the day, as it were, is not actually all that long ago. And in fact, many of you may even still be doing this, right? You created your application. And then the way that the users experience this application is that the customers downloaded the app, they installed it on top of an operating system. In very many cases, they had to provide a whole bunch of other technologies for the app to run. Maybe it was a version of Java. Maybe there were specific device drivers for a piece of hardware. And their legal and security teams were responsible for pretty much everything but an application that you delivered. And this worked, but there were lots and lots of problems with this approach. What we tended to find was that, and there were problems really that impact us from a CI/CD perspective, because what it really meant is it was very, very hard to test. So you couldn't really talk about any sort of continuous delivery because the customer is is managing all of the pieces. It was very, very hard to test it. I remember I lived in a lab that had 30 different laptops configured in different ways that we would install our application on and then go out and try to run the application on each one of them. And this really was what containers look to solve. Let's wrap it all together. Let's provide the application with its entire stack. We can worry about all of the security aspects of it from a centralized point, so you know exactly what the application is running. And most importantly, you get rid of the idea that what works on one machine doesn't work on another machine. Now, containerizing in some ways seems very simple, but there are some catches. But the first pitfall that you run into is downloading a file is cheap, Docker containers are bigger. And so there's this huge temptation that says, oh, let people build their own Docker containers. I'm not going to worry about it. It'll be faster for everybody involved. Now, you wouldn't do that with binaries, right? So I've got up here kind of a standard flow of how your software application works, right? You build once, and then you get a binary and you promote the binary so that in production or your customer, they get the exact same binary that you compiled and built. And the reality is you want to do the exact same thing with your Docker containers. You build your Docker container up front, you test that Docker container that's built, it has everything in it, and then that Docker container that you have tested is what you put in production or what you give to your customers, either one. And now, when you talk about promoting, there's a couple of different ways you can do it. So what does a Docker container look like? It looks like it has, some set of layers, and then at the top it has a manifest. And it's very important that you tag your Docker container. Sure, you've got this beautiful SHA-2 that you can use to uniquely identify it from here on in, but it's completely meaningless. It doesn't let you know, is this Docker container newer than that Docker container? It doesn't let you know what's in the Docker container. And it's very, very easy as time goes on to lose sight of all of it. And so when we talk about promoting, we can talk about tagging it. We can talk about, oh, we have the 1.0-dev, we have the 1.0-QA, the 1.0-release as separate tags of the same manifest. And that's a great approach. We also often find our customers prefer to put the true production images in a separate Docker registry. And this is to make it so that from a permissions perspective, you don't want, any dev may have access to the dev Docker registry. In some cases, any dev can write to it. And when you talk about a production environment, you want something much more locked down. And so when you talk about a promotion process, you might actually be moving a Docker container from a dev Docker registry out to a production Docker registry. Now, as we start talking about these promotion processes and building out Docker containers, traceability is critical. We want to build once and promote, but we also want to make sure that we know what version of the software it was. I've had the experience of, many years ago, I remember getting the experience of having 2 CDs with software that tells you some about how long ago it was, with the same version number on them. And I go and we installed it across 30 different locations using these 2 CDs. I gave the 2 CDs to the 2 techs. They went out and installed on every machine. And half the machines didn't work. We call somebody up, we do some research, we discover that we had 2 CDs with the exact same label and different software. And this is a big problem because there are advantages in Docker to the concept of a tag that moves, right? If you look at, say, the tags for your average base layer, right, you have a moving tag that represents this is the most secure, up-to-date version of it. But on the other hand, you need that traceability. You need to know where it came from. And so what we typically recommend is a double tagging approach. You have one tag that never changes, that's based on the build or some unique identifier that you preserve and that gives you traceability to where it came from. And then you have another tag that says, this is the good image, this is what you should be using right now today. But when we've gone to containerization, we actually end up with 3 CI pipelines that we've created now. Because I still need to test my app. I still have things that, I'm working on in kind of the standard basic, maybe I built a war file, as is so common at JFrog when we're building something. Maybe I build out a war file. I know how to build Java test pipelines. I've got that and I'm testing it, and that's awesome. Then I have another test pipeline in here, which is often overlooked, which is what we call the base layer. And this is, what does your technology stack look like? And you test this technology stack against a known good version of your application. And this allows you to iterate the base layer very quickly so that you can do things like do those security patches without impacting whether the application works, and without worrying that you have somehow broken the application. You don't have any question when the final container, which is the final pipeline, combines the base layer and the app and ships your containerized app. And you never want to have a question when that containerized app fails test. You always want to know, where did the failure come from? Did it come from the base layer? Did it come from the app? Is it something specific to the new combination of the two? And by having these three independent pipelines, you've got maximum traceability. And maximum traceability also means maximum automatability and the ability to have very, very high confidence in your pipeline, and also the ability to automate everything and know and contain breakage in ways that it doesn't propagate through a system, so that if something goes wrong with the base layer, you're not holding up all of the other pieces. And so how does this actually look? It looks a little bit like this. I have my Git step where I check code in. I then run builds with my various tools, whatever they are. Kind of outside the pipeline, somebody else has been working on creating out base images. And then I combine my application binary with my base layers, and I get out a new application that I've created. And when we build out this Docker container, we have to be careful when we build it. So there's a variety of things that we need to be paying attention to in this containerization process and in the CI/CD for this containerization process. One of them, of course, is security. While there's lots we can do later in Kubernetes to lock down network access and try to prevent bad actors from accessing portions of containers they shouldn't get to, it doesn't change the fact that if you have insecure containers, you have insecure applications. And you need to have some sort of security tool that you're applying throughout this process. At JFrog, obviously, we provide JFrog X-Ray, but there's a variety of other security tools that exist out there, and you need to be scanning your Docker containers. You need to be scanning your base layers. You need to be scanning your application layers. You need to understand how this all goes together. Another subtlety that comes in here is understanding how your Docker layers are going to change. So when you're deploying Docker images, your Docker images can get quite large. Now, there's things you can do to mitigate that by paying attention to how you build it and making sure that you don't have a lot of extra cruft in your Docker images. But the other thing that you can do to mitigate this a lot is, if you pay attention to where you expect the changes to happen the most frequently, you can work to build out your layers so that you have big bottom layers that don't change very much, and then smaller top layers that change frequently. Now, you also, if you're doing this sort of approach, you may end up with a lot of layers, and you may end up with small, as it were, patch layers on top of bigger layers. And you do want to make sure that you don't have too much cruft accruing in terms of the total number of layers. If you see a Docker image that has 20 layers, that may be legitimate, but you should go through and you should look and see, do I have a lot of layers that are layering over layers underneath and just replacing binaries on layers underneath to provide updates, because then you know, I'm wasting time. I'm wasting time in deployment. I'm wasting network bandwidth in deployment, and I'm just making everything take longer than it needs to. And I have really seen massive improvements in efficiency and time basis just by putting some thought into how your Docker containers are constructed. And this absolutely still applies to Kubernetes, because at the bottom of a Kubernetes stack, you still have effectively Docker and Docker images with layers. Now, the other question that you may be asking yourself now is, yay, I have containerized my application, and therefore I've got microservices, right? Well, when you start looking at this containerized application, if you took an application and you containerized it, and now you're looking to deploy it into production, and you're asking yourself, is this really a microservice? You think about, well, what's the core responsibility of this microservice, and what else is this microservice doing? And very often this microservice is doing a lot of other things that the application needed to get started. Did it, you know, maybe it bootstrapped a database. Maybe it's checking that the database is up before it starts certain aspects of things. Maybe it still has tools on it that were used for building it. Probably it has some sort of logging capability that's built in. If you've just taken a, you know, sort of a classic monolithic application and put it in a container. And so we want to do a little bit better on really separating out the pieces. And I'm not going to go into too much depth about, you know, how you do migration to microservices, because there's lots of other good talks about it, but there are some basic things that we're trying to do. We want to identify a common feature set between containers, and if there's multiple containers that have a common set of features, probably that should be pulled out into a separate microservice. We also want to run our main production microservices with the minimum privileges possible, right? This is kind of basic security problems, right? You don't want to expose anything in runtime that you don't have to. And Kubernetes gives us a lot of very awesome solutions to do that. We have initialization containers that can do a lot of the things that require elevated privileges. We have a sidecar pattern to start abstracting out services. Kubernetes itself provides a lot of sort of the basic application monitoring tools that you need, so you don't need to include them inside your application. And leveraging this is a lot about how we start productionalizing our pipeline and how we achieve true DevOps, right? Because I said at the beginning that we're starting to build on top of things, right? We're not really replacing steps that we had to do before. We're adding new steps to what we used to consider our CI/CD pipeline, but those steps are allowing us to truly release to production with confidence. So if we go through this initial iteration of the process, you come up with something like this. You've got a volume, you have a main container, you have some subcontainers, you have some dependent microservices, and I know if it's live or if it's ready. And there's more best practices that I now need to start engaging in. One is resource consumption. When you start looking at all of these containers and you start adding more and more of them, resources matter. They're not free. You don't want to start trying to pay too much attention to resource consumption too far up front, but you do need to pay attention to it. It costs a lot of money to run unnecessary processes. You need to understand also which ones need to scale. You also have to worry about modularization. You need to be able to have the same application runtime deployed in multiple environments, a dev environment, a staging environment, a prod environment. And in general, we recommend that you kind of your default values be the ones for staging, not the ones for prod, not the ones for dev, but your staging environment should be the environment that's close to prod but not actually prod. You need to pay attention to the network layer. As I said, it's very easy with any sort of microservices application to say, oh, just expose everything. But in reality, what you want to do is you want to very carefully wire up services so that they only expose to each other the extent that they need to. And at least with my own team, we found that when we started with Kubernetes, the network layer was the place that we were struggling with the most, probably because it was the area that our developers had traditionally not worried about. That was somebody else's responsibility. And as we brought in expertise on operational systems, this became a lot easier. And I suppose I want to mention here kind of another little side note when it comes to this whole process of DevOps CI/CD, and that is that sometimes we think when we talk about DevOps that we have a myth that one guy writes the code, containerizes the code, deploys it to production, supports it, and all of those things. And in the case of a small and trivial application, this might be possible. But for larger ones, we're not talking about one guy, we're talking about a team. And that team should have expertise in different areas of the life cycle of the product. They're all working together to achieve the total life cycle, but you have different expertise. One guy is a real expert on coding Java business logic. One guy knows the networking pieces cold. And they work together and they collaborate together to build a better tool. And that's really what DevOps is about. It's not about a rock star programmer, it's about a team. And the final best practice that I want to point out is if we're talking about CI/CD for an operational application, you must test the operational aspect of it, what Netflix charmingly calls chaos testing. You have to test, is it scaling up and down correctly? Can you move services to another node correctly? And of course, if you've done everything else right, this will just happen. This is what Kubernetes does. But very often in the course of doing this testing, you'll find interesting errors with the persistence layer, or an interesting error with the network layer, or an assumption that a certain piece of code made about that other things are going to be co-located in ways that they're not. And this aspect of it is going to be very important as we move forward. So this is why we went to Kubernetes, right? Is we want to be able to manage deployment. We want to be able to manage, the state, the jobs, understand how to manage secrets. And this is what Kubernetes does for us. And it looks easy enough. One thing I'm going to say, and I'm not just saying it because Rancher was kind enough to sponsor me on this thing, is I've worked with a lot of customers in their initial deployments of Kubernetes. A number of them had a temptation to say, okay, I'm just going to, kind of take Kubernetes as is and install it and run it. And it's possible, but it's a lot of work. It's very, very hard to do. And if you have a tool like Rancher or GKE or lots of other tools, don't try to roll your own Kubernetes. Let somebody else do it. They'll walk you through the setup process to make sure that you have all of the pieces. And I can't stress this enough. I've spent months trying to work on problems with applications that turned out to be underlying issues with the Kubernetes install. And I've never had that level of problem with somebody that took any really of the base Kubernetes distributions, whatever one you might want to be, whether it's one of the public cloud flavors, whether it's Rancher or whatever, it really just simplifies the life a lot. So now quickly, I want to talk about, we've kind of gotten basically to the modern world, and let's just quickly summarize where we've gotten to as we talk about a production application. So we started with code. And we realized that code becomes an application. And it's an important point to note. In the modern world, the application is not just your code. It's your code plus all of the third-party library dependencies you got from open source to build your application. And in many cases, that's well over 90% of the application. And then even beyond the application, you have the technology stack, which gives the rest of the third-party applications, of the third-party pieces that your application requires to run. And then that in turn is built on top of a runtime environment, which gives all of the pieces. And then the biggest part of it all becomes the production context. And this is where Kubernetes comes into play. And if we look at this, this is a lot of different technologies that come into play. We have Git for the source code. We have, some set of technologies that we're using when we're writing our application. Pick the language of your choice. And these together, they constitute the application part of what we're building. And kind of the old way of mainline developing applications, there's a lot of it that still applies. Now we have the application technology stack. And maybe this comes in with RPM and Debian packages and a runtime environment, which becomes a Docker container. I get asked sometimes, if we have Docker containers, do we still care about package management? Can I just put the binaries on that I want? And to some extent, of course, you can. But first of all, package management makes your life easier when you're building, and why turn away a tool that makes your life easier? Perhaps equally importantly, a lot of the tools that analyze security work much more easily if you have the package management layer to tell them what's actually there, what's inside your Docker container. Oh, you did it all with Debian? Oh, I know how to find Debian packages and how to tell you if they're vulnerable. You did it with Maven? I know how to find Maven packages and how to tell you if they're vulnerable. This is what tools, what a lot of the static analysis security tools like JFrog X-Ray and other tools like it do. And together they build out, this application technology stack, this runtime environment. They build out that base layer. And then, as we said, you take the base layer, you take the application binary, you combine them together, and you get the Docker app. And then you have your production context. This is in Kubernetes. And the way you build out this production context is with a Helm chart. Now, in the spirit of shameless promotion, you might ask, is there one place where I can store and manage all those package types? And I just took that pyramid and I highlighted it green. Everything in green, which is basically everything but the source code, can be stored in JFrog Artifactory. And JFrog Artifactory can be deployed one click from the Rancher Marketplace. And that is my shameless plug for my employer for the day. Go ahead and try it out. Getting back to the production context, Kubernetes has a lot of capabilities. In theory, can just deploy things to Kubernetes by themselves. But there are some challenges. How do I know what the wrapper script is, what the context is going to be? How do I do dependency management? What should just the simple conventions be for naming files and folders as I'm trying to build all this out? Kubernetes templates don't allow a lot of advanced logic. It's not uncommon for an application to involve 10 microservices, 5 of yours, 5 that are third parties. You're tying them together. You have to suddenly name all of them. You're going to have a lot of copy and pasting as you're deploying things. And as you're going between different environments, you may need logic specific to the environment, which you then can't do in base Kubernetes templates. If you're using Helm, this gets much simpler. The wrapper scripting is all done with the Helm CLI. contextualizing everything together is very easy because you release the Helm chart with all of the Docker containers associated with that Helm chart. If you want to use subcharts for third-party dependencies, you can do that. There's basic conventions built into Helm on how to name things out. And if you need advanced logic in your template, you have Go templating to do the work. And if you're not familiar with Helm, the basic way Helm works is you have a Helm client, it contacts the Kubernetes cluster, and it runs the Kubernetes deployment. And it makes deploying packages on Kubernetes much easier. The reason we care about it in CI/CD is because it also makes it much more reproducible and much more reliable, much more reusable and versionable. And in general, the process of install, upgrade, rollback, delete, all of these CD tasks become much easier in the context of Helm. And you have the ability to go out and provide templates for your helper objects. You have the values.yaml separated from the chart.yaml, so you have a values.yaml with the parameters. If you were to look at the sorts of charts that JFrog puts out, because we have to deploy to many, many environments, you're going to see detailed values.yaml. And in general, when we customize it for something like Rancher, we can make all of those changes still in the values.yaml without overly impacting the upstream chart that we provide. And so the basic pieces of it is pay attention to your Go templating, use it when you want to. Pay attention to your storage layer. Where are you dynamic provisioning? Where are you static provisioning? Understand the differences between both and do it well. And again, pay attention to your network. Make sure that you can configure it appropriately. Now, another thing that we've run into a lot that I just wanted to call out as we're doing this is that when we first started, we ended up spending a lot of time maintaining new copies of third-party templates that tweaked a couple of parameters for us or did kind of the initial runtime install. Maybe we had specific users that we needed to install for our security model. We've moved away from this and thus vastly simplified the number of things that we are responsible for testing separately, as opposed to relying on the base test that we're inheriting from other people. By having these post-install hooks, right? So we run a script after somebody else's Helm chart runs, and that script then goes out and does the minor modifications to the environment that we require. And of course, the script is then maintained by us. So Helm is pretty cool, but it does add another level of CI. So before I had my app, I had my base layer, then I had my app in the container. Now I have my operational app in a Helm chart, and it also needs to be tested with the new unique tests that the Kubernetes environment has to worry about: scaling, chaos tests, performance, etc. So when we talk about JFrog Go Center, which is a scalable, exposed to the public service that any developer can use, we ended up with 5 different environments that we had to create in order to cover all of the different types of testing and interaction that we require. So one of the environments we have is our CI cluster. So the CI cluster is where the base CI integration tests of the master branch take place. Whenever we uptake new version dependencies, the basic chaos tests, all of these things happen in the CI cluster, right? And as developers are making commits, it runs out and kicks it off. Now we also have a dev cluster. The dev cluster is what our developers use while they're working on their feature branches. This is particularly important for those developers that are responsible for the operational context of the system, but also in general when you start having microservices and you need to work on how the two microservices are interacting, this dev cluster becomes very important. We also have a test cluster. So the CI cluster is designed to go very rapid iterations through the product. So you can commit and it will get into CI very, very quickly. The test cluster is where we run our longer tail tests, right? This is where we do a much more extensive set of chaos tests, a much more extensive set of load tests. We also, starting here, we start doing upgrade tests. Our production environment has to be able to do a rolling upgrade. We aren't bringing it down, upgrading and bringing it back up again. We have to be able to do a rolling upgrade, and we have to make sure that the persistence layer updates of those upgrade tests are working very, very well. And then we have the staging cluster. And in the staging cluster, we have, again, upgrade tests, because staging is treated exactly like production. We only provision it exactly the same way as we provision production. So it has to be able to do a rolling upgrade test. This is where we actually do all of our UI testing. It's about the only stage in this process that involves any manual intervention whatsoever. We typically have somebody check the UI by hand as well at this stage, just to take a look at it, and a load test. The stage cluster doesn't per se have explicit chaos tests, but one of the things we did very early, Go Center is deployed on GKE, and one of the things we did very early, working with Google, especially in our stage cluster, but in general throughout, is we use preemptible VMs. And preemptible VMs, only last 12 to 24 hours as a general rule, and we typically leave things in stage longer than that. So we kind of automatically get base chaos tests as VMs get as Kubernetes nodes get preempted and have to be respun automatically in the background. And then you get your production cluster. Now, we're not running any CI/CD tests on production cluster per se, but there's always a latency check. We're running checks from various locations around the globe to our production instance URLs, checking, can the UI be accessed, can the APIs be accessed, what is the latency of that? We don't do this, but I have a colleague at another company I know that is part of their prod tests, quote unquote. They have a Twitter sentiment analysis bot running that checks to see if if Twitter sentiment suddenly goes down after they've done a release to prod, they consider that a failure of the production rollout and consider doing a rollback environment. And at least in one case, they do that automated as part of their canary test from a Twitter bot, which I thought was really cool. But in general, the point is, no, you're not testing staging in production, but you are, you're not running CI/CD tests, but you should be running basic tests against your prod cluster to know if things are going well or going wrong. So I've done a lot of talking here. I'd like to get to the demo. So I'm just going to quickly talk back to our anatomy of the production application. I'm going to show you 4 Jenkins pipelines: an application war pipeline, a Docker image template, a Docker image product pipeline, and a Helm chart, just so you can kind of see how most of these practices, not quite all of them, go in production. We'll just quickly look at the code in a couple of places. Sorry about that. For some reason, 1 second, sorry, I'm having a quick issue with the sharing. There we go. That working better now? Okay, so here's our app. And you've got version 1.0.1 of the app. And I figured we might as well change that. And this is just our standard Gradle application that we do demos of all the time at JFrog. It's completely open source, and I just went to the wrong folder. Oops. There we go. And I again went to the wrong folder. 1 second. Sorry here. There we go. Web service. Source. This is how you know that it's a live demo, is because I'm screwing it up. Web app. There we go. Index. So we're going to update to 1.1.0. And we're going to commit. Now, of course, I've already kind of violated a best practice here because I'm going to commit directly to my live branch. As we talked about, we have an entire environment for Go Center that we strongly recommend, where you're going to have feature branches and you're going to test your feature branches in the dev environment before you commit to your main branch. But in this case, we're just going to commit it. And then in normal circumstances, what would happen now is this Jenkins job, I have 5 Jenkins jobs, the same anatomy we talked about, creating the application war, creating the Docker image template, the Docker image product, creating the Helm chart, and deploying it. In normal circumstances, this would trigger automatically. For the purposes of this demo, I'm triggering each step manually. So I'm going to build it. And as this is building out, we'll look really quickly at the Kubernetes example of our Gradle. What is this Jenkins file actually doing in the background? And the reality is it's checking out some code. It's building it with Gradle, and then it's running a very basic test to run it, and then it's publishing it to Artifactory, and running an X-ray scan of the build to look for any security problems. And you may have noticed I'm going to actually leave the security scanning off simply because it adds not so much it adds a little bit of time, although it does, but more because you never quite know when a security vulnerability is going to creep in, and I didn't want to have the demo break in the middle because of new and unexpected security vulnerabilities. But as a best practice, you should be running security scans at every step of your application build process. So I also mentioned the Docker image template. And so we can kick that off. And if we look at the Jenkins file for the Docker image template, it's actually a little bit more interesting. It's called Docker Framework here. I look at this Jenkins file. And what's interesting about this is, first of all, it goes in and it gathers the Java version and the Tomcat version that we want. And then it builds out a Docker image that becomes the Docker framework. It tags that with the unique name of the build, as we mentioned, with the dynamic tagging. But then it runs this test phase. And this test phase is pretty cool. So what is it doing? It's pulling out the release version of the web service war from the release repository of Gradle. It's downloading that. It's making it accessible to the Docker file. And it's building that Docker image and testing that Docker image before it it promotes the Docker framework. So it's actually testing against the last known good version of the app to make sure that nothing is broken as we update the base layer. And then again, of course, it runs an X-ray scan and promotes it. And then while we're looking at that, we can quickly go and look at this Docker framework image in our registry, just to kind of see what we've built out. This is going to be pretty boring because if we look at it, all of them have the same manifest. So it's a little bit hard to tell. When we go to the Docker app, this will change because I've been making changes to the code. But in the framework, this is a very static build environment, so it doesn't change very often. And so you can actually see that this tag gets reused many, many times for the same manifest to represent every time it's been built. But this is good because I still have traceability to everything I did. And then we start getting into the exciting pieces where we're triggering the Docker image product. So again, we look at this Jenkins file. And we're gathering the web service. We're building a Docker container that includes that web service. And then we're testing it and promoting it out. And if we look in Artifactory on this one, if I've managed to get it fast enough, we can actually see the stage in prod, and it looks like, you know, this one, the X-ray scan is still pending. But we can see now that version to version, the manifest tag is changing. And so this version 2.11, which is our newest one today, represents the new manifest tag. And now we're going to start going into the quick parts. We're going to build out the Helm chart. And we are going to deploy it with Rancher. So one quick thing on the Helm chart that I want to show you that's, again, an area where we're not really following a best practice in this demo. And it's largely because I didn't want to take the risk of having to edit the code in multiple places. If we look at this values.yaml, we'll see that this is using the latest tag of the Docker app. And this is not a best practice. What we should be doing whenever we deploy a Helm chart is specifying the version of all of the containers so that this is a reproducible deployment, and then incrementing the version of the Helm chart every time we do so. Now, it's a still very minor fix. You could almost automate. In fact, you absolutely can automate, and we do in something like Go Center. We automate updating this tag number in the values.yaml and then incrementing the value of the Helm chart, but it makes it much easier to maintain traceability as time moves on through this process. And if we go over here at this point, oh, I haven't run the deploy yet. Yes. So now we're going to run the deploy here, and we'll go into Rancher. We'll watch our container. Refresh it. And you can see that the old 2.11 pod is unavailable still. It's removing 2.10. And if I rescale it again, we can now see that it's now running 2.11. Please ignore the error messages up here. That is again, the joys of doing live demos. we switched WebSockets here. And now if I go over here and refresh, I'm running 1.1.0. And that's the basics of a CI/CD pipeline throughout the process. Thank you very much for your attention. So we can look now back here. 1 second. Screen issues. So I've walked you through the application more, the Docker image template, Docker image product, the Helm chart. We didn't really do any chaos testing of the Helm chart, which we should have done because of the fact that that takes a fair amount of time to properly do chaos and performance testing. Although I'll be happy to talk about that if you have any questions. And in general, the point is test everywhere, build up from what you had before and increase and improve as you're getting to production grade systems. Use a distribution for your Kubernetes, use a binary manager, use Helm. Production style testing should be part of CI/CD, and always pay attention to security. Thank you very much for your time. Do you have any questions?
Thank you, Mark. Yeah, there are actually a bunch of questions, and we are almost out of time. So let me run through some of the most interesting ones, and please try to answer in brief. Yes. And you can just point people to resources so they can follow up. How does the rollback work?
So rollback with Helm is pretty basic, right? Effectively, what you're doing in most cases is you just tell it go back to redeploy the old chart effectively. Okay. And that's the point of having really well-versioned charts. It makes rollback much easier to do it that way.
Okay. What mechanism did you use to deploy to Rancher?
So on that one, we just did a very simple, I guess I didn't actually show that Jenkins file, but it's actually the simplest of all of the Jenkins files that we have. It just runs, let me just bring up the command so I don't quote it wrong. It just runs basically the Rancher Helm chart deploy. We just use the Helm CLI to deploy to the Rancher basically.
I think in general, I'm seeing a couple of questions around, the artifacts that you used, and if you can probably share those, then a lot of these questions will be answered.
Yeah. So again, I want to repeat that the entire pipeline that I used in my demo is at GitHub JFrog training Kubernetes-example. Okay. Anybody can look at it. If you have questions about it, you can also file issues there. My team monitors that repository, and if you have questions, we'll be happy to answer them.
Perfect. Why or how should somebody decide to choose Artifactory over anything else like Docker Registry or Harbor or anything that you can think of? Like if you can just summarize, like why Artifactory?
So I think there's a couple of reasons that Artifactory has been chosen by so many people for this purpose. So one of them is just a very good HA and scaling model, which is very sort of natural in a Kubernetes environment. It's highly available very easily. But I think maybe even a bigger reason is it's more than just a Docker registry that you need. To build up everything you need for Kubernetes, you need Docker, you need Helm, but you also need all of those application pieces. Probably you need RPM and Debian, you need Java, you need Go, and Artifactory does all of that in one place. And most people, when they start comparing their options, they realize that Artifactory is just easier and better.
Okay, so basically you're saying it's a one-stop shop for all your images to be stored.
Yes, exactly.
Okay. I'm sure if there are follow-up questions, people will reach out to you. How do you manage authentication to Rancher or Kubernetes? and where do you manage secrets?
So that's a good question. In a lot of our demos, we tend to leave a good chunk of the secrets pieces inside Jenkins, basically, and use kind of the Jenkins credentials plugin, just because it's easy and it doesn't involve a lot of extra infrastructure. But we also use very heavily, and when we're talking about our actual production environments, we build out a secrets vault in Kubernetes through the Kubernetes processes for creating a secrets vault, and we leverage that Kubernetes secret vault for basically all secrets.
Okay. What are the advantages of using Rancher with Kubernetes instead of only Rancher or only Kubernetes? Okay, I think I'll answer that. So guys, Rancher helps you manage, deploy, provision Kubernetes clusters, and you can have multiple Kubernetes clusters managed by a single pane of glass in Rancher UI. You can have Kubernetes running on-prem in GKE, in EKS, in AKS, and they can all be managed from a single UI, and that's Rancher. We have our own distribution of Kubernetes as well. It's a production-grade Kubernetes, but it's like very small image, so the footprint is very small. So if you want to go and try it out, look up K3S. You can do a search on Google for K3S, and that's something that we announced a couple of weeks ago. So in a nutshell, Rancher helps you create and manage Kubernetes clusters, and you can do it. You can do multiple of those, and it comes free with a lot of. Rancher is open source, so it's all free to use. And then you get a bunch of other capabilities in Rancher, like how to monitor, how to log, how to alert. You deploy applications on multiple clusters at the same time. Deploy a global DNS. Tons of applications that I cannot go through. So everything that you need to manage your Kubernetes in just one place. Installing Rancher takes about 2 to 3 minutes end to end. That's all it takes, 2 to 3 minutes. So if you have 3 minutes, go try out Rancher. Just go to rancher.com and install it, and then you will know what I mean. Let me see if there are any other. There are a lot of questions which are like half written. Yeah, there are a bunch of questions about sharing your YAML files and GitHub repo link, but I think you already pointed that out, Mark. Would you deploy different stages of the application to different Kubernetes clusters with help of Rancher, or same cluster? So basically the question is about multi-cluster approach versus single cluster approach.
That's a fair question. So the answer is we do a mix of separate namespaces and separate clusters. So for us, the production cluster and the staging cluster, both of those are separate clusters, because we don't want any sort of, we want the staging cluster to be exactly like the production cluster, and we don't want any workload interference from non-prod activities in production. It isn't to say that we wouldn't be willing to make our production cluster. We are willing to make our production cluster multi-tenant, but we only want production-grade things running on it, so that we don't have something weird happen from some weird dev artifact. When we get to all of the other ones, those are typically just separate namespaces on the same cluster. We think that namespaces are very safe in terms of being able to multi-tenant namespaces on the same cluster. We think that's a perfectly reasonable approach to take, and we do a lot of that. As I said, the only reason we don't do it in prod is because we have a lot of we want to make sure that we understand exactly what the performance implications are only of our prod artifacts. So we don't want to do anything non-prod there that might interfere with our ability to understand kind of how that cluster is functioning based on production workloads only.
I think, this is a question that I often hear about Rancher, multiple clusters versus single cluster. And it depends also on your security posture. And if you want to kind of create an isolation and privacy and security, and cluster is your boundary, hard boundary, then go for it. If it's namespace and you can live with that, then you can get done with just a single cluster. And then if you're using Rancher, Rancher actually provides you something even better. We have something called projects. Project is a combination of namespaces, which is controlled through RBAC. So that provides you a higher level of isolation in the single cluster, and you can do that. But if you want to go the route of multiple clusters, go ahead. With Rancher, you still have a single pane of glass UI to manage all those clusters. So I think it depends on how you think about your environments. There are a bunch of other questions. Let me ask you at least one more. What about dealing with air gaps where production is separate off of the internet? So basically, I think the production environment is air gapped. That's the question.
So a lot of the people that I work with on a regular basis have either their dev environment or their production environment air gapped. And the great thing about the process that we went through is that for the most part, it doesn't matter. If you've got some sort of binary management solution, whether it's Artifactory or something else, effectively the trick is that you have to move the binaries from the binary manager on one side of the air gap to the binary manager on the other side of the air gap, and then everything just works. And one of the awesome things about, before I joined JFrog, I worked as a contractor for the United States military. So we had air gap environments all over the place. And one of the great things I think that Kubernetes and containerization brings into air gapped environments is a guarantee that you've actually got everything. One of the big problems that we would have is, you'd always end up, moving binaries over across the air gap and realizing that you forgot some critical dependency that wasn't properly recorded or that sort of thing. And on the one hand, it was a great way to make sure you had actually correctly recorded all your dependencies. On the other hand, it was a royal pain, especially since those particular air gaps often took, many hours to cross. And so with this sort of pipeline where you've got everything and you've got everything in one binary manager, it becomes really easy to just clone those pieces that have been promoted to production over across the air gap and into the production repository. So this is kind of the binary manager, you have promotion, so you know exactly what you have to move across the air gap, and that's what you move, and it works really well. And it's something we do on a regular basis with customers, honestly.
Okay. There's a question about Windows, and let me ask you from your perspective, do you guys, Artifactory and X-Ray and all the other tools, do you guys support Windows and Windows containers, basically?
So Artifactory runs on Windows and has for years. The rest of our applications do not. And we debated whether we wanted to issue a Windows container of Artifactory, but at this point, we haven't seen a lot of demand from our customers for that sort of thing. I think has a lot to do with sort of the nature of our application. We're a deep infrastructure application, and we've increasingly seen people kind of moving away from Windows into Linux-based environments for that type of environment anyways, even among our customer base. Although, of course, Artifactory itself can store Windows containers, as a Docker registry. But we've never really seen the need to provide a Windows container of it. I think if we were more concerned with user space, if we were, say, the makers of an IDE instead of, binary storage and management, I think that we would probably be issuing Windows containers. I think it's the classic question of who is your consumer and what is the consumer, how does the consumer want to consume?
Okay. The same question was asked for Rancher as well, and Rancher does support Windows containers, by the way, guys, but in experimental stage, and we are waiting to hear from Microsoft and about Docker, where they are headed, and Kubernetes, of course, where they are headed with Windows containers, and if there is going to be a serious release about that. So I'm hearing Kubernetes 1.14, maybe that release, but we are not sure yet of how it will work and what stage Windows containers will be. But for now, you do have a support in Rancher for Windows containers. If you want to go try it out, please do. It's all on our web on how to do that. Do Helm charts deploy to Rancher projects in the same manner as Kubernetes clusters? Okay, not sure I fully understand, but just to give you an example, if you do deploy apps using Rancher, and you are using something like a catalog app, then you can point it to a particular project in a cluster, and then that app is available inside that project. So hopefully that answers that question. In Artifactory, do you utilize Docker image proxy for deploying dependent image like Alpine base image?
So in the case of this particular pipeline, absolutely. We're using a remote Docker registry. Like the Docker framework image in this case is based on Ubuntu, and that's still pulled from the Artifactory by using the remote repository of Docker Hub to proxy it so that you have it stored locally for scanning, that sort of thing.
Okay, I'll ask you a last question, Mark. Thank you for staying back, but let me ask one more. Is your build environment containerized, and does it run on Kubernetes cluster?
So the answer is that some of our build environments are containerized and running on Kubernetes, and some are not. We're kind of in the middle of making that transition at JFrog, and depending on which build environment you're looking at, it may or may not have reached that stage. But we actually, basically all of our new ones are in that way. So Go Center works that way. We're actually going to be releasing a whole new build environment for another community shortly that's going to be working that way. And our internal one is in the process of being transitioned to that type of model.
All right. Okay, there are a few other questions, but I'm sure, Mark, you have to run and I have to run as well. Thank you, everybody, for joining. Thank you for all your enthusiasm and all the questions. We host this every week, so next week we'll have a new topic. Please do go and look up Kubernetes Masterclass at rancher.com. We have a whole page where we have both the topics as well as what those topics are about. You can also find recordings to the past sessions that we have held. Feel free to reach out to us, send us an email, call us, whatever you need, we can answer. Rancher is open source, so you're not paying for using Rancher. And with Artifactory, I think you saw how it all kind of comes together if you want to deploy a full end-to-end your build release environment. Thank you very much, Mark, for joining.
Thank you. It was a real pleasure. Have a good one.
You too. Bye-bye.